Morning, YouTube. Today I wanted to talk a little bit about models. Now, sure, I could tell you something like go into R, type in LM, dependent variable, little squiggly fellow, and then add all the independent variables that you ever want, and boom, you got a model. But this isn't really that kind of video. This video is really important because it's going to help you save lives. Maybe, depending on your model. I don't know. But if you scroll through YouTube, just like you just did, and you happen to pick this video, welcome, by the way. This is a really nice place. You should subscribe and hang out. Nice here. They may tell you something like this, or they may tell you model specifications, or they may go into the math a little bit, or they may tell you about Cook's distance and how to identify outliers in your model, or they may tell you about p-values and how you should love them. P-values are your overlord, by the way. Now you're already in this world. Are you really ready to build a model? I mean, really? Are you really ready to build a model? Getting this question wrong could lead to discriminatory business practices, just a waste of time. You're going to have to come back and do this model again. You could lose a massive gambling bet, or you could lose credibility, or you could cause death. Yeah, death. For example, the Challenger explosion that killed 7 of some of the brightest minds in the world was caused due to model misspecification, due to biased data sampling of O-ring failures. So this video is going to be different than any you've seen on this channel, and probably different than any that you just scrolled past, but it's really important. You should stick around to the end. I cover some important topics. This is a pretty short video. I mean, just stick around. And I don't even know if we're going to ultimately build a model in this video, and that's probably a good thing. So let's assume today that you have a website. Congratulations, by the way. And let's say it's a website for crayon sharpening. Like crayon sharpening really fast, and maybe on that website you have a blog post and videos and merchandise and just a bunch of other stuff. And the data you collect from your visitors are things like how often they visit, their age, if they bought merchandise from you, just stuff like that, the whole shebang. So this isn't really a far-fetched example. Facebook does more or less the same thing, and then they build a model to squeeze out every ounce of interaction from us. Like we're some sort of pulverized orange. I don't know. So you or your boss think, oh, gee whiz, this would be a great time to build a model. We got all this data after all. Why don't you go and do that? And then maybe at that point you typed in some search words into the YouTube bar up above and you found this video. Hey, welcome. So first up at bat, let's think about it. Do you really have all the data you need? So imagine a circle which contains the answer for all of the questions why somebody would visit your website. And really only a god could put this together, or some divine being would be able to craft such a circle. Because things in this circle are like the chemicals in your brain that told you to stay on the website. The hues of color that influenced why you were there, maybe the types of crayons, maybe they just got up and got a cup of coffee, and that was why your website was open a little bit long. Maybe somebody sneezed, and that's why you got a little bit more view time on that video. Just all of those kinds of things are in this circle. And some of the things in this circle are also some of the data you have, like somebody's age or if they bought merchandise. So really only a god would know this data generating process, or DGP. That's what that means, by the way, if you've ever heard that. So now that you've listed out every possible reason why somebody would increase their watch time on your website, now look at your data. How much of your data answers that question? Or if you keep the circle and you start adding some overlapping circles on the outside, how much of that center circle is really mopped up by all of this? And while we're at it, do any of your outside circles overlap each other and create this kind of like three-way Venn diagram where the interaction between two variables are also answering that center question? Take a note of that because it'll come in model building. And if you were to draw a DAG plot, that is a directed acyclic graph, would you be missing any steps in the middle, or would a variable at the end also predict something earlier on? Does watch time increase the likelihood of you buying merchandise? It's probably a two-way relationship. So take note of that as well, because that's going to come up in model building. And so at the end of all of these theoretical steps for your particular example, which by the way, this takes a lot of time. This isn't like a one and done kind of thing. And you should also shop these ideas around other people and get their idea. It's the scientific process. This is what we're doing right now. At the end of all of this, if you do this and you find that you really don't have a lot of data, or there's something easily obtainable, or now you're starting to identify outliers in your data set, then maybe now isn't the best time to build a model, but just down the road, you could see having one. So all I mean to say is that you should really think about these questions before starting your model and see if you can get additional data, build some data relationships, or answer some questions about the individual variables in your data before you ultimately tackle that big model question. So enough about the independent variables. Let's talk about your dependent variable a little bit, which the dependent variable is the left hand. It's like the y in the equation. It's the thing you're really trying to answer. It's watch time, your watch time for your CRAN website. Let's think about that dependent variable. Does it change over time? The answer is yeah, probably. For pretty much every case, actually. As people get more connected to the internet, as people browse more content, or as your content gets more popular, watch time is going to change. Maybe it's seasonal. Maybe there's a massive pandemic that has people clutching to childhood feelings and happiness. Who knows? What this means is that your data is always biased to a particular point in history, and the data that you have is only for a particular snapshot of time. And so you're biased to what you've observed so far. And what you're doing is you're using the data you have to predict something down the road. And having something down the road happen is only going to be predictable if it happened in your data set. So just to really drive this home, let's change up some of the variables and add a layer of seriousness and ambiguity. Yikes. So let's assume you are a data scientist for the TSA in America. Congratulations, by the way. You are tasked with predicting if a flight customer will have drugs, a bomb, or some other dangerous device that they shouldn't have. And so TSA would pull them aside and throw them in a slammer or something. I don't know what the TSA does. If we only have data of instances that were from the month September 2001, we would have a pretty biased data set. And this model would probably end up being very discriminatory against people, and that'd be really bad. And so although you may be really, really curious about building a model and saving lives, and you really believe in this project, you may not have a particular good data set to answer this question just yet. So in this case, we may be pressured to add variables like race or socioeconomic status, where someone is from, into the model. But just like teaching an AI to be racist, this model would be no different. At the end of the day, an AI is just a tangled web of models, and so we should treat ours like that. Perhaps the variable we really need is an interaction between incident history and political or socioeconomic strife in the current time point. So if the person is from, let's say, Somalia, sorry, Somalis if you're watching, and there happens to be political or socioeconomic strife in Somalia, then maybe that checks the box for somebody we may want to look out for, given all the other variables in our model to predict an incident problem. And ultimately what we would have here is a more sustainable model going forward, and it doesn't have you suggesting that TSA pull every single person out that is of color. So thanks for doing that, TSA, if you're doing that. I don't know. So what's left? Well, there's a lot. There's determining the kind of model, checking the model outputs, crying over p-values, then minorly adjusting things so that way you get acceptable p-values. The important stuff is up next. But this video has already really gone long enough. I kind of wanted to keep these under 10 minutes. I really wanted to share some introductory thoughts about model building that I think is really important, something that isn't really talked about much on YouTube. I hope you learned something today. Take it from me, a guy who failed probably 100 models just to get one right. After all, you reached the end of the video. Hey, thanks for watching.